So here's a question for you AP Stats folks. In the last video, in the last little bit, we learned how to use or how to find a strategy for finding the proportion or the area given a value. But what if you wanted to go the other way? What if you were given the area or like the proportion and you wanted to work backwards and find the value that corresponded to that proportion or that area? You're still going to go through a 3-step process here, and the steps are very similar, but there is a little bit of a difference, and there's a different calculator step involved. So the first step is the same. Essentially, you're going to draw the normal distribution with your horizontal axis that's labeled and scaled, the area of interest shaded, but now your boundary value is unknown, but you can clearly mark what it is, as far as like, hey, I don't know this, I want to find it. From there, you're going to do your calculations. In the previous way, when you were trying to find the area or the proportion based on the value, it was, kind of a toss-up whether you wanted to use Table A or technology more. When you're working backwards in this way, you're probably going to want to use technology more than using the table, but I will still show you both ways. So if you're using the table, you would need to find the value of the z-score that has that indicated area under the standard normal curve, right, with the mean of 0, standard deviation of 1. And then you need to unstandardize it, so transform it back to the original distribution. Or like I said, you can just use technology, and I'll show you how to do that. And then finally, as always, answer the question that is being asked in the context of the problem. As far as what this looks like in your calculator, so when you go to your second vars, instead of clicking normal CDF, you're going to go to the next option, which is inverse norm, I-N-V-N-O-R-M. So that means inverse norm. So inverse in mathematics is usually the opposite. So when we do normal CDF, that tells us the area based on a particular interval. This will give us the basically the interval or the point based on a particular area. 2 different ways you can use inverse norm, just like there were 2 different ways you can use normal CDF. If you want to have it standardized, you would use 0 and 1 as your mean. If you just want to use the values that were given in the problem, you would do it this way. Another difference there is that you would find the percentile versus like the value that was given to you there. Now, depending on the model of your calculator, you might see an inverse norm screen that looks like this one here on the left or the one on the right. I think the one on the left is if you have like a newer, like a TI-84 Plus maybe. If you have the older one, it's always going to assume you're putting in the area to the left. Just like the table always tells you to the left, it's going to assume you're doing the area to the left. If you have the newer version, you can choose if it's a left area, a center area, and we'll see an example like that later, or a right area. I always default to left. So if you have a calculator that's like this, you just have to be careful then with how you write your work. So a little bit about the calculations on the calculator. Like we said, normal CDF gives you the probability of obtaining a value between 2 values, and that can include like this infinite idea. There is a normal PDF, and that tells you the probability of precisely doing something. And then inverse norm gives you the x value based on a given probability or percentile. So that type of question might look like, Tommy scored a 92% on the test. What proportion of students did he score better than? Something for us to know, we will never, ever, ever use normal PDF in this course. Okay? Do not do it. Let's look through an example here. According to the CDC, the height charts of 3-year-old females are approximately normally distributed, mean of 94.5 and a standard deviation of 4. 75% of 3-year-old girls are taller than what height? So first things first, always, always, always sketch it out. You'll notice how my x-axis, I have a label, and I put the mean in the center, and then I've counted out 3 standard deviations on each side. So go ahead and sketch that out. After you have a good general sketch, we want to shade in the area of interest. So it says 75% of 3-year-olds are taller than what height? So they're basically asking for a minimum height. So that wording there is signifying, hey, it's like a right-tailed shading. So 75% obviously is 50% is at the mean, so it would be to the left of the mean, a value smaller than the mean. And so we shaded in, it's an approximate thing, right? We don't know exactly where it is, so we just have this general like X. But notice how I'm noticing that if 75% is to the right, that means 25%, or 0.25, is the area to the left. So here's our calculations. If you're using the table, it's kind of like a scavenger hunt. You need to search through the table to find the z-score that has the area closest to 0.2500. Okay, it won't be exact, but it's the closest. And we find that it's negative 0.67. So then, this is why I said use technology, okay? Because using inverse norm is going to give you the exact same thing. Now, if you did the standardized version, that's fine, where mean was 0, standard deviation was 1. Now you just need to do a little bit of algebra and solve for that unknown value that led us to that z-score. Okay, and we get 91.82. Now, if you do it in the calculator straight off, using the mean of standard deviation given to you, again, same area, it's going to give you a really similar value. I would recommend probably using the second option, but you just, again, have to be sure you're labeling, hey, this is the area, this is the mean, this is the standard deviation. As always, answer the question that was being asked. So about 75% of 3-year-old girls are taller than 91.8 centimeters. All right, a quick review on z-scores, right? Z-scores are on the margins of that table A. Z-scores represent standard deviations. We learned that in the first section. When you're putting it in the calculator, those are the 4 things we do for normal CDF, and it answers the type of question, what proportion is greater than this. Areas under the curve to the left of the z-score are in the middle of the table and the body of the table. That's what we just talked about with that inverse norm idea. So the area represents the proportion that's to the left, right? To the left, to the left. That would answer a question similar to this bottom one, how many standard deviations away from the mean is the 60th percentile? So in general, when you're trying to solve a problem, you want to draw your curve and fill it in with as much as you can. Shading, labeling values, etc. Doing your calculations, you only need to pick one of these. Either standardize it and use the table, or just straight off use technology. Okay. And then, as always, write your final answer in a sentence, including context of the problem. We're going to go through an example here. It is pretty lengthy, so it might go into another video, but we'll see what we do. In the 2008 Wimbledon tennis tournament, Rafael Nadal, I'm going to say Nadal, averaged 115 miles per hour on his first serves. Assuming that the distribution of his first serve speeds is normal, capital N normal, with a mean of 115 miles per hour and a standard deviation of 6.2 miles per hour. I think I use 6 in all of my calculations. I do. So if it doesn't say 6.2, or it says 6 on yours, I'm going to use 6. So you might want to change that so yours says 6. So first question, about what proportion of his serves would you expect to exceed 120 miles per hour? So here's our question. What proportion would exceed 120 miles per hour? First step, give it a sketch. You can see that I have my x-axis here. I forgot to label. I should have a label down here that says first serve speeds in miles per hour. And then I put 120 just here, just shortly below 1 standard deviation from the mean. And my question is, what is the area of this shaded, right? Exceeding means above it. Now let's go through. I'm going to show you how to do it in both ways. You only need to pick one though. So we want to standardize that speed of 120. So we'll find the z-score that corresponds to 120, and that's 0.83. Again, I'm using 6 as my standard deviation. That was a typo in the previous slide. Now that I know that the z-score was 0.83, I'm going to use table A to figure out the proportion to the left of that value. So using my table, I go to 0.8 in this column, 0.03 up at the top, and I go together and I see that it's 0.7910. Okay, and I can see that here. 67. I was reading the wrong thing. 0.7967. Now, we don't want to the left of that though, we want it above that. So because we wanted the probability or the proportion of the z-scores that's greater than 0.83, we need to subtract it from 1. Why? Because the area of the curve is always 1, which gives me a value of 0.2033. The other option is using just technology. So you go to this normal CDF screen. We would put 120 as my lower, because that's the lower bound. Some really big number for the upper. There is this little like E button that you can use on your calculator, or just put in like a bajillion. The mean here is 115 and standard deviation was 6. The way you would record that, showing your work, is what you would write here. All of this, labeling what each number is. Finally, we conclude in the context, we expect that 20.33% of Nadal's first serves will be greater than 120 miles per hour. You could also say we expect that about 20% of Nadal's first serves. So if you're going to be rounding it more, make sure you're using the word about. All right, I'm going to give you an option. If you want to pause this video and try the next couple examples, B through E, you can. Here are the answers, like as far as like the numbers that you will get. Obviously not the exact, written statement that you would have, but here's the approximate numbers. I am going to explain it here. If you, pause and then unpause, I'll explain it in this video, and it will probably go into a second video as well. So if you want to see how I get them or exactly how you show those works, please continue watching. After this example, there's another example in your notes. I'm not going to work through that on the videos, but that's like your quote-unquote homework that I need you to work through after you watch this video, showing all the steps, sketching the curves, writing down your work, writing your final answer, and then we'll go over that in class. All right, the next question. What percent of Nadal's first serves are between 100 and 110 miles per hour? So I have my first step. I sketched it out, and I shaded in my interval, labeling those numbers. Next step, using the table, I needed to do the z-score for both of those. So do it for both 100 and 110, and I get those z-scores here. Then using the table, I would look in table A and find the proportion that is to the left of each of them. Finally, what I would need to do is I would subtract the two areas to find an area of 0.1971. That's using the standardized version and table A. You can also use the calculator. So if you're using your calculator, you would do your normal CDF. Lower limit is 100, upper is 110, mean is 115, standard deviation is 6. And again, to record that, you would write this line here. So you'll find it's a similar number. Writing our answer in full sentence form, about 19.71% of Nadal's first serves will be between 100 miles per hour and 110 miles per hour. Next example, the fastest 30% of Nadal's first serves go at least what speed? So this is that question that's kind of asking, all right, I'm giving you the percentage, what value corresponds to it? So my curve is going to look a little different. I still have my numbers for my mean and my standard deviations, and I have my shaded area. I know it's going to be somewhere between the mean and one standard deviation to above it, simply because if I remember the empirical rule, 68% is within 1 approximately. So half of 68 is 34. And then, if you did 50 minus 34, it would tell you what's further out, so I know it's going to be between there. So here's where I can use the table. Again, I wouldn't recommend this way, but you can. If you want to use technology, you would put in your area to the left, depending on the type of calculator you have. Find the z-score is 0.52. Do a little bit of algebra to work backwards to solve for your value. All right, so multiply both sides by 6, add 115. The other, probably more preferred option is to just put it in your calculator using all the values they give you. It's a lot faster. And then finally from there, you're going to conclude in the context of the problem. The fastest 30% of Nadal's first serves go at least 118.12 miles per hour. I'll answer the next two examples in the next video.